People, hope we're doing well today. This is going to be a couple of videos on application problems of implicit differentiation, primarily tangent line problems. So let's start with this one. This is a rotated ellipse. The differentiation ought to be relatively straightforward. So let's go ahead and hop to it. If we have x squared plus xy plus y squared, then we basically need to differentiate term by term. Now, if we're getting the derivative with respect to x, then x squared, because it matches, becomes 2x. We need to do the product rule for the middle. So we have the first times the derivative of the second plus the derivative of the first times the second. And then, of course, y squared, we've done this several times, becomes 2y, y prime. And, of course, the mistake that so often happens when you're doing implicit differentiation, you're concentrating so hard on getting this right, you'll forget that the derivative of a constant is 0. Now, we have two terms that are y prime, okay? And we need to basically isolate them, or just in terms of just leaving them here on the left side and get rid of the other two terms, right? So we have x, y prime, plus 2y, y prime, is equal to negative y minus 2x. Let's go ahead and factor out the y prime. Negative y minus 2x, and then y prime is equal to, and we can put the negative out in front if we want in order to not have quite as many negatives throughout here, make it look a little bit nicer and neater. Now we're going for the equation of the tangent line at 1, 1. So we need to go ahead and evaluate y prime at 1, 1. Okay? So we're going to get negative 1 plus 2 times 1, 1 plus 2 times 1. So that's going to be 3 over 3. And so the slope is going to be negative 1. So we're just going to have y minus y1 is equal to mx minus x1. And this winds up being y minus 1 negative x plus 1, or y is equal to negative x plus 2. Now, I mean, you're welcome to leave it in point slope form as far as I'm concerned, but oftentimes, especially if you're, doing it out of a textbook or something like that, or if it's a multiple choice question, they'll oftentimes put it in slope intercept, and of course that shouldn't be very, very difficult for you. Now, the point 1, 1 is, if this is 0.8, this is 1, so it's the point right about here. Okay, and if we were to actually draw that tangent line, okay, it would actually go through the point 2 right here and go through the point 2 right here, and it would look something like this. And that visibly, that one was easy because it didn't have an irrational slope or something like that. That one was easy to go ahead and see. Okay, let's do one that's a little bit more fun. This is called the Follium of Descartes. Yes, that Descartes. And we're going to find the equation of the tangent line at two separate points, one of them being 2/3, 4/3, and the other one being 4/3, 2/3. So that's fun. So let's go ahead and let's do the derivative. So we have 3x squared plus 3y squared y prime, and of course over here on the right hand side we're going to have to do the product rule. We'll pull the 3 out and let that coefficient come along for the ride, and we have x y prime plus y. We now have 3's throughout here, so we can divide through by 3, and then we are going to go ahead and let's collect the y prime terms over here on the left, and the non-y prime terms over here on the right. And so we have y prime, y squared minus x is equal to y minus x squared, and y prime winds up being y minus x squared over y squared minus x. Now I simply need to evaluate this derivative at both of those ordered pairs. Let's do the first one. So we have y prime at 2/3, 4/3. So we have 4/3 minus, and that's going to be 4/9, y squared is going to be 16 ninths minus 2/3. Now I could get a common denominator and blah, 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 but let's just go ahead and multiply by 9 over 9, and that's going to make things much easier. When I multiply by 9, this one and this one obviously lose their denominator. This one loses its denominator, gets multiplied by 3, so it's 12 minus 4. When I do the same thing here, it's going to be 16 minus 8. Therefore, it is 8 over 8, which is 1. All right, let's go ahead and see what happens when I'm looking at the 4/3, 2/3. Okay, when I do this, it's going to be 2/3 minus 16 ninths. And then, of course, the y squared is going to be 4 ninths minus 4/3. I don't have to do this because obviously this numerator is the negative of that denominator. This denominator is the negative of that numerator. So I'm just going to get negative 8 over negative 8. The slope here is also 1. Now, if you wanted to go ahead and look at this graph and estimate it a little bit better, if 1 is right there, then 2/3 is here, and 4/3 is that point right there. Okay, and 4/3, 2/3 is going to be, so we notice that there's a symmetry across the y is equal to x, so there should be a symmetry to the tangent lines that are occurring there as well. And I basically just have to say, well, y minus y1 is equal to m times x minus x1, and of course the same with the other order pair. It doesn't matter what order you do it in. And so those are my two tangent lines. And I could clean them up a little bit if I wanted to put them into my calculator and actually look at them. So that first one becomes, when I add 2/3 to both sides, this is going to be x minus 2/3. And when I add 4/3, this is going to be x plus 2/3. Now if you want to visualize that, we can. Let's go ahead and pull up the graphing program, okay? And we're going to introduce a new equation. And let's do, okay, so that winds up being x cubed plus y cubed is equal to 3xy. Okay, boom, and there we go. And we're going to have to zoom in just a little bit in order to get a good idea of what that bad boy looks like. And then we can introduce two more equations and just make this x minus 2/3 and introduce another one with x plus 2/3. And we notice that both of those look like they are tangent at their particular point here and here. And therefore, basically it's always nice to kind of get a visual on what you've been doing, and that's all we're doing here. You don't really have to graph them if you don't want to. But if you'll notice on the worksheet that I posted, I did include something like this for the two that we did in class. Okay? Every once in a while I'll pull it out because it's always nice to get a pictorial representation of what we're doing. Let's move on to the next one. This is called a limison. Now, unfortunately, because of the pandemic, you weren't able to get all the way towards polar graphing because there's actually a much easier way to represent this in terms of polar coordinates, but, whatever. Now, what we're going to do here is this winds up being a little bit tricky. And the reason this winds up being tricky is we're finding the equation of the tangent line at each of the 4 points on the curve where x is equal to 1. And so let's go ahead and let's draw x is equal to 1. And notice that I'm looking for the tangent line here. I'm looking for the tangent line here. I'm looking for the tangent line here. And I'm looking for the tangent line here. Oh, isn't that wonderful? Okay. Now, what I need is first of all I need to find the derivative so that I can find the slope at each of those 4 points, but I also need to actually find those 4 points. So let's go ahead and do that first. Now I know if I'm finding each of those four, I mean all of those, basically I'm looking for one something, right? And therefore I just need to plug 1 into here. So I'm going to get 1 plus y squared minus 4 squared is equal to 2, 1 plus y squared. So this winds up being y squared minus 3 squared is equal to 2, 1 plus y squared. And basically what I'm going to need to do is I'm going to need to go ahead and multiply this out into a polynomial. I can't see any other way to do it. There might be another way to do it, but it's escaping me right now. Oh, well that might actually be helpful. Here, let's try this out. Let's leave it in this form right here, and notice that this is y squared plus 1 minus 4 squared, and this can be brought over as 2. Y squared plus 1 is equal to 0. I can FOIL it out like this and get y squared plus 1 squared minus 8, or sorry, yeah, 8 y squared plus 1 plus 16 minus 2 y squared plus 1 is equal to 0. Obviously this and this wind up being like terms. Okay, so I have y squared plus 1 squared minus 10 y squared plus 1 plus 16. And, you know, it would have been just as legitimate to actually do it out all the way. Unfortunately, I'm using pencil on this one, but I'll just keep going. This winds up just being a quasi-quadratic, right? And so what I get is it factors as y squared plus 1 minus 2 and y squared plus 1 minus 8. Okay, and of course these can be simplified. This winds up, you know, becoming y squared minus 1 and y squared minus 7, and so I get 4 solutions for y. I get y is equal to plus or minus 1 and plus or minus root 7. So my 4 ordered pairs are 1, 1, 1, negative 1, 1, root 7, and 1, negative root 7. So I need to find the tangent line for all 4 of those. Thankfully, the numbers aren't too disgusting, so we'll go ahead and we'll just keep working that. Now I need to find the derivative, and I think I have room enough to at least get started. I'll tell you what, let's just go ahead and let's start on a separate sheet of paper. This is x squared plus y squared minus 4x squared is equal to 2 x squared plus y squared. Okay, let's go ahead and continue on this page. And now that I have the ordered pairs, I need to get the derivative. I need to get y prime and then plug them in. So this winds up being stuff squared, so it's 2 times stuff times the derivative of that stuff, right? So it's 2x plus 2y, y prime minus 4. And over here, this just becomes 2, and this becomes 2x plus 2y, y prime. Now, thankfully, that 2 and that 2 can very easily be canceled out. Also, you're going to need to, you know, the 2 in here can be canceled with the 2 in here as well. And so you're going to get x squared plus y squared minus 4x, x plus y, y prime minus 2, and then x plus y, y prime. Now, the only problem here is that y prime needs to be released. Now, here's the thing. If I were just finding y prime, I could go ahead and multiply this trinomial by this trinomial. But since I'm actually evaluating, it's probably going to be easier to do the multiplication once I actually plug in the numbers. So this is the derivative. It's just not solved explicitly for y prime. So I don't have to wait until it's actually set like y prime is explicitly in terms of x and y. I can go ahead and plug in my ordered pairs and then solve for y prime, it makes it much, much easier. So let's go ahead and evaluate it at 1, 1. And so this winds up being 1 plus 1 minus 4. And then 1 plus y prime minus 2 is equal to 1 plus y prime. You see how that makes it easier? This is negative 2, and this is y prime minus 1, and this is y prime plus 1. This winds up being negative 2y prime plus 2, y prime plus 1, and so we'll get 3y prime is equal to 1, or y prime is equal to 1/3. So for 1, 1, we get y minus 1 is equal to 1/3 x minus 1. There is my first tangent line. Let's go ahead and do it for 1, negative 1. Okay? We just have to be careful when we're plugging in. The last one, it didn't really matter because they were both 1, and I just sort of rushed through it, right? But here, it's x squared is definitely going to be 1. Y squared, well, you're plugging in a negative 1, but it's squared, so it's 1 again, minus 4. Now this next one, it becomes 1, but now here the y is not squared, so that term now needs to take on the negativeness of the y right here, and then minus 2. And this over here is going to be 1 minus y prime again. Now this again becomes negative 2. This becomes negative y prime minus 1. And this over here becomes, is still, 1 minus y prime. So when I distribute the negative 2, I get 2y prime plus 2 is equal to 1 minus y prime. We get 3y prime is equal to negative 1, or y prime is equal to negative 1/3. Now, noticing the symmetry of this, the bilateral symmetry across the x-axis, it should not be a surprise that if the slope here is 1/3, that the slope here should be negative 1/3. Okay? And therefore you get y minus y1 is equal to negative 1/3 x minus 1. And that is your second tangent line. Okay, well this next one's going to be a little more difficult. Okay, so let's go ahead and rewrite our derivative up here. Okay, and let's evaluate this at, what was our other? Okay, it was 1√7. Okay, so let's do 1√7. And of course, if that's the case for 1, 1, and 1, negative 1, that there's a relationship between their slopes because of the symmetry, there ought to be a relationship between 1√7 and 1, negative √7 as well. But we'll get to that here in just a moment. So we have x squared plus y squared minus 4x, and then we have x plus, and this is √7 y prime minus 2. And then over here we have 1 plus √7 y prime. Well, this is 8 minus 4, so this is 4. This winds up being √7 y prime minus 1. And this is 1 plus √7 y prime. For √7 y prime minus 4, and 1 plus √7 y prime. If we gather these on the same side, we have 4 √7 y prime and 1 √7 y prime, which gives us 3 √7 y prime, and I'm adding 4 to both sides. So I get y prime is equal to 5/3 √7. Which, is kind of disgusting, but, and we can estimate this. Remember that since 7 is between 4 and 9, and of course, there's no halfway between 4 and 9, but it's pretty close, right? It's 3 units from 4 and 2 units from 9. That right there is probably somewhere around 2.5, okay? So if that's 2.5, this denominator is roughly 7.5. So this right here is probably going to be somewhere around 2/3. And we can, of course, we can get our calculator out and do that. But, it's just always nice to have an estimate just really quickly in your head. And from here, of course, I now have point and slope, and I have y minus y1 is equal to m times x minus x1. And that right there is my tangent line, okay? Now, I know that there's likely going to be a relationship between the slope here and the slope here, since there are corresponding points across an axis of symmetry. But just for the sake of being exhaustive, let's go ahead and do it, just kind of do the arithmetic anyway. So it's going to be 1 plus 7 again, right? Because it's squared, the negative goes away, minus 4. So that first trinomial, we're going to get the same value. Here we have 1 minus root 7 y prime minus 2. And on this side over here, I'm going to get 1 minus root 7 y prime. This again is 4. This again is negative root 7 y prime minus 1. And this is 1 minus root 7 y prime. So we get negative 4 root 7 y prime minus 4 is equal to 1 minus root 7 y prime. And this winds up being negative 3 root 7 y prime and 5. So, we see, in fact, that it winds up just being the negative of what we had on the other side, which we kind of predicted. And so you have y plus root 7 is equal to negative 5 over 3 root 7 and x minus 1. Okay, so there are your 4 tangent lines. Now, of course, it was much longer because I was looking for 4 tangent lines instead of just 1 tangent line. And of course, it was longer because I wasn't given the ordered pair. I actually had to find the ordered pair. But none of it was overly burdensome. None of it was overly hard. It just wound up being tedious and burdensome at times. But of course, like I've said before, repetition, pedagogically advantageous. So, good for learning. I'm going to go ahead and call this one to a close. We'll do a couple more application problems. I don't know whether it'll be one or two more videos, but either way, I'm going to go ahead and run through the problems that I have until such time as I believe that I've given you sort of adequate resources for shoring up the understanding if you still don't understand after we're done in class. As always, please do email me if you have a question. Bye.